Okay, so good morning to everyone. So in the previous classes, we have seen about the IPv4 address and supernetting and subnetting conditions. So today we will see the another type, that is the IPv6. So today we will see about the IPv6 address notation. Like same, like in the IPv4, also we have seen how the address notation is presented. Same as that for IPv6 also there is the address notations are present. And there is a technique used in IPv6, that is the zero compression technique. And IPv6 also has the packet format. We will see that. And what are the changes? What are the changes that is made in the IPv6 that is not present in the IPv4? We will see that. So before starting that, we will see that IPv6 address. Now, basically, the IPv4 address we have seen that is of the 32 bits, or we can say of the 4 bytes. This is the IPv4 address format. But in case of IPv6 address, it is 128 bits or 16 bytes. That means the length of the address in IPv6 is the 4 times maximum of IPv4, because IPv4 the address length is 32 bits, but here in the IPv6 it is 128 bits. That means 4 times larger, 4 times the length is the 4 times the length of the IPv4, and there it is 4 bytes, but here we are using it as the 16 byte. That means 4 times higher. Now, why this IPv6 address came? Now, for the IPv4, we have seen that through IPv4, our total address space, in the total address space is 2 to the power 32. And 2 to the power 32 means we have seen that 2 to the power 32 address space are present. But let's say that devices, day by day, the devices are increasing. So that means what? That means this number of devices we have already covered by giving the IPv4 address. Now the new devices day by day it is growing. So IPv4 address is not possible to give that address space for all the device. Then what we will do? For that reason, this IPv6 addresses are came. Now through IPv6 address, we will use 2 to the power 128, 2 to the power 128 the address space. That means this is much larger than the IPv4 address space. So that's why we use the IPv6 addresses now. Now, same as that for IPv4 also the notations are present. Here also the notations are present for IPv6. For IPv4, the notations, 3 type of notations we have seen. That is the binary notations, then dotted decimal notation and hexadecimal notation. These 3 notations we have seen. For IPv6 also, we have 2 notations present. One is dotted decimal and another one is the colon hexadecimal. Now, why this dotted decimal, but this dotted decimal notation is used? Now, it is not used very much because we didn't use the dotted decimal notation, but this notation is also present in the IPv6. Now, dotted decimal notation is used for the IPv4 compatibility. That means the previous devices, whatever the previous devices we have, that previous devices are used IPv4 address. Now, the new devices which came, it is using the IPv6 address. Now, what we have to do? For our easy purpose, we have to make all the previous devices which are using the IPv4 address, we have to convert this to the IPv6 address. But it is very time taking and a difficult process. So what we will do? We will use some compatibility. That means this IPv6 address devices make compatible with the IPv4 address devices. So to make the compatibility, we use this dotted decimal notations. Now, if we use the dotted decimal notations, then the address will look like this. this address, it is very much, that's why I'm saying that we didn't use the dotted decimal notation, because you see here there is 16 bytes, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So the address will be look like this, that is, you see 221.14.65.11.105.12.170.34.12.234.18.0.14.0.115.255. So like this, if we write using dotted decimal of IPv6 address of any device, this will look like this. So if we using dotted decimal, if we write the IPv6 address of any device, then it will look like this, because 16 bytes, so that means there will be 16 sections present. So it is very difficult for remembering this type of address, the IPv6 address. So it is very much difficult. That's why we didn't use this dotted decimal condition. We didn't use this dotted decimal notations here, because if we use the dotted decimal notation, it will be very much problem for us to remember. That's why basically we prefer to use the colon hexadecimal. Now colon hexadecimal is what? It is the notation which is used to make the address more readable. That means if we use the sorry, if we use the colon hexadecimal format, then the address space or the address will be more readable in the format. Now in this notation, the 128 bits, in this notation, the 128 bits are divided into 8 sections. That means this 128 bits we divide into 8 sections. Now 8 section means each section will contain 16 bits, because 128 bits are divided into 8 sections. That means each section will contain 16 bits. Now 16 bits means what? 16 bits means bytes. That means 8 bits equal to 1 byte. So the 16 bits means it will be 2 bytes. So that means 8 sections, and each sections will contain 2 bytes in length. Now 2 bytes in hexadecimal require 4 hexadecimal digit. So this is the format of our see, it looks like the example. If we go to it, then the example will look like this. You see, FDEC means total how many sections will be present? 8 sections will be present. You see 1, 2, 3, 4, 5, 6, 7, 8. And each section contains how many bytes? Each section contains 2 bytes. Each section contains 2 bytes. That means each section contains 16 bits, and each for 2 bytes in hexadecimal require 4 hexadecimal digit. So that means it will look like this. Hexadecimal, we can use the hexadecimal here. So the address will look like this, FDEC colon. That's why it is named as given as the colon hexadecimal, because we can use colon here. That is FDEC colon BA98 colon 7654 colon 3210 colon ADBF colon BBFF colon then 2922 colon FFFFF, because we can use the hexadecimal number also here. This is the hexadecimal, and here colon is used, colon hexadecimal, because we are using colon between each section, we are giving the colon. So that's why its name is given as the colon hexadecimal. So basically, basically during the IPv6, if we write the IPv6 address, basically we follows this colon hexadecimal format. This is the format we basically follows. Now the next topic is the abbreviation technique. Now what is this abbreviation technique? It is the technique to reduce the length of the IPv6 address. Means for reducing the IPv6 address length, we uses this abbreviation technique. Now, how we reduce this? How we reduce the length of an IPv6 address? Now, length of an IPv6 address is done by omitting or removing the leading zeros of a section. Now, these things you should have in the mind, leading zeros. And this is also called the zero compression. Not only the leading zeros can be dropped. That means we only able to remove the leading zeros. So let's say there is an address. Through example, I will explain it. Let's say there is an example. It is given, that is FDEC colon 0074 colon 0000 colon 0000 colon 0000 colon B0FF colon 0000 colon FFF0. So this is the address it is given. Now we will use the abbreviation technique. Now the abbreviation technique says we have to remove or omit the leading zeros. Now here in FDEC there is no zero present. So we will write that. No problem. Now here 0074. So here these two zeros, they are leading because before 74 these two zeros came. So they are leading. That means we will only take 74 here because these zeros are leading. Now, in case of this 4 zeros, what will happen? Now, you can say that we will first remove all the zeros, but it is not possible. We will remove all the zeros. Then the address will be changed. So what we have to do? We have to reduce maximum zeros. Now, we have to reduce the maximum zeros. So how many zeros we can able to maximum remove from here? Here, 4 zeros are present. So maximum, we can say that 3 zeros we can remove. The maximum 3 zeros we can remove from here. So that's why we remove 3 zeros from here. Here also the same rules are applicable. Maximum zeros we can reduce. So here also we are taking only 1 zero. Then here also the same rule applicable. So we take this. Now in this B0FF, yes, from here we cannot remove the zero because this zero is not the leading zero. This zero is not the leading zero because this zero is came between this B and F. So that means we have to take this B0FF, we have to take total. We cannot remove zero from here because this zero is not the leading zero. From here, this maximum zeros we can reduce. So from here also only 1 zero present, and here FFF0. From here also we cannot reduce the zero because this zero is the trailing zero, because before this zero FFFF is coming. So that means this zero is the trailing zero. So we can not remove zero from here. So the address will look like this. So this is the address. We can say this address will be called as the abbreviated address. This address we can say, we can call it as the abbreviated address. Now, if the combination, we can also be able to remove the combination of zero. We can able to, if we again remove, again abbreviated that, or again steps in the next step, we will remove the combination of zeros. Combination of zero means here you can see 3 zeros are present. So this is making a combination. So from here, this 3 zeros we can reduce, and we will only use this 2 colon for saying that there is a gap present. You see, from here we are using these 2 gaps. That means if like a combination is made, if like a combination we make, from here we can reduce this combination. So that's why all these zeros we removed, but we have to say that there is a gap present. So that means these 2 colons, this colon and this colon, we have to write. You see, this colon and this colon, we write here. But we cannot reduce this zero because there is no such combination arises, because here is not zero, here is also not zero. So that means the combination not arises. So if the combination not arises, then we cannot remove 0. So that's why you cannot able to remove the 0 here. So this is the condition for the abbreviation. This is the abbreviation of IPv6 address. Okay. Clear to everyone? It is clear? Okay. So now we will move the type of address in the IPv6. The type of address we used in the IPv6 address format. Now first we will use there are 4 types of address present in the IPv6 address space. That is the unicast address, multicast address, anycast address, and broadcasting and multicasting. This type, and a reserve address. Another one thing is the reserved address. So these are present. So first we will see the unicast address. Now what unicast address define? It defines a single interface or a computer. So unicast means, uni means what? Uni means single. So that's why it defines, unicast address defines the single interface or a computer. Uni means single. So that's why it defines the single interface or a computer. And the packet sent to the unicast address will be routed to the intended PC or recipients. So let's say there is an example, it is given that there is a source present and another one is the destination. Now let's say source is using the IPv6 unicast address. That means this source is using the IPv6 unicast address. And using this IPv6 unicast address, it sent a packet. So whenever it will send a packet, then through router, this is a router present. So that through this router, this packet will go to the intended PC or the intended destination. So this is the unicast address. So source is using some unicast address, IPv6 unicast address, and it send a packet. So the packet is transmitted to the router, and from router, the packet will go to the intended PC, or we can say the intended destination. So this is the unicast address. For multicast address, what is for multicast address? Now these are used to define a group of computers or a host. And in this, each member of the group receives the packet. That means if we see this example, here you see there is a source present. This is a router, and there are a number of systems. There are number of computers that are present, A, B, C. This is the systems, number of system present. And these 3 systems are forming a group. These 3 systems are forming a group. So let's say the source is sending some packet. The source is sending packet using IPv6 multicast address. So source is sending packet using IPv6 multicast address. Now the packet will be transmitted to the router first. Now router will do what? It will send all the systems that are present on this particular group. That means the packet will be transferred to all the system. All the system in the group, all the systems that are present in the group. So this is for the multicast address. That means the packet will be transmitted in all the systems that are present in the group. So this is for the multicast address. And next is the anycast address. So what is the anycast address? Same as multicast address, but there is some difference present for the anycast address. Now here also the group will be present. That's why it is said that defines group of nodes or a computers that all share a single address. And a packet with anycast address is delivered only on the one member of the group, which is the most reachable one or the nearest. That means here also the group will be present. Here also the group will be present. That means the systems, these 3 systems, let's say this A, B, C, these 3 systems are present and they are forming a group. This system, this total 3 systems, are forming a group. Now there is a router present and there is a source also present. So let's say the source is sending some packet with IPv6 Anycast address. Using IPv6 Anycast address, source is sending some packet. So that packet will go to the router. Packet will go to the router. Now router will do what? Router will route all the systems. That means it will go, it will see, router will route all the systems. That means it will do routing that in which distance, which is the smallest distance between them, the smallest cost or the smallest distance is present for which device. Now let's say in this example we are seeing that A system has the nearest distance because B's distance is much, C's distance is also much. So that means this is this system between this A, B and C. This A is the nearest to the router. So router will do what? It will see that which system is in the nearest. It will send to which system is nearest in the group. In the group, which system is nearest? It will send the packet to that system. That is why it is said that in the packet with Anycast address is delivered to the only one member of the group, which is the most reachable one. That means it will see and router will route the all the systems, and it will find that the most reachable one, the most reachable or reachable one, or the nearest system. So if it finds the nearest system, then this packet will be transmitted to the nearest one. This is the concept of the Anycast address. So this is the difference. But in the case of multicast address, we have seen that the packet will be sent to all the system that is present in the group. But here the packets will be only sent to the system that is the nearest to the router, and that is the most reachable one. So this is the difference between multicast and Anycast addresses. Now, the fourth type is the broadcasting and multicasting. Now, IPv6 doesn't define the broadcasting. IPv6 doesn't use the broadcasting address and considered it as the special case of multicasting. So broadcasting, it doesn't happen in the IPv6, and it considered the special case of the multicasting. And the final one is of the reserved addresses. Now this reserved addresses is used for the reserved purpose, and also the reserved addresses, we can say this reserved addresses have start from the we can say this reserved address, this so this reserved addresses, in this reserved addresses we have total 8 zeros, and this will start with the 8 zeros. Okay, so these are the 5 types, of address space we used in the IPv6. One is the unicast address, the next one is the multicast address, then third one is the Anycast address, and fourth is the broadcasting and multicasting, and the fifth type is for the reserved addresses. And this reserved addresses is used for reserved purpose, and it starts with 8 zeros. So this is all the types of address space in the IPv6. So now we will move to the packet format of the IPv6. So in the previous class, we have seen about the IPv4 packet format. Same as that for IPv6 also. For IPv6 also, there is the packet format present for IPv6. Now in this IPv6 packet format, it is broadly defined, derived with 2 types. You see, these 2 types broadly distributed. First one is the header, and the next one is the payload. This packet format, or we can say datagram packet format, IPv6 datagram packet format. So it is broadly divided into two things. One is the header and another one is the payload. These 2 types it is derived. Now header contains the 40 bits. Header contains 40 bytes. Sorry, not bits. Header contains 40 bytes. And the payload. Now you say that you can say that what is the payload? Payload means that the data that is to be transmitted. Payload defines that the data which we will transmit, that defines the payload. And this payload will up to, this payload length will be up to 65,535 bytes. So that means this, that's why we are saying that IPv6 address is, the length of the IPv6 address is much more than the IPv4 packet format. IPv4 packet format, for this length of the IPv6 is much more, because in the IPv4 protocol, the packet format, if you remember, there is the header and the data. These two divided into two parts. One is the header and another one is the data. But here in the IPv6 packet format, it is broadly divided into header and the payload. So header is 40 bytes and payload is can be up to 65,536 bytes. And payload is basically the data that is to be transmitted. Now, this header is the base header. This header, we can also call it as the base header. We can also call this as the base header. So let's say we will first, now in the packet format, we will see how this will be divided. How this will be divided, we will see. Now, this base header format, this header is like this, it looks like this. Now, in the base header, there is multiple fields will be present. In this base header format, the fields are the first field is the version, then second field is the traffic class, third field will be the flow level, and fourth field will be the payload length, then fifth will be the next header, and sixth will be the hop limit, and seventh and eighth will be the source address and the destination address. So this is the format. It looks like this. The format look like this. Now, first field, that is the version. The first field, that is the version. Now, version field is used for what? You already know that in IPv4 also, in the header format, version field is present. Now, version field is basically 4 bytes. The version field is basically 4 bytes, and it simply defines the version number of the IP. Means which version IP address you are using, this version field will show that. So that means in case of IPv4, the value of this field will be 4 because it will be the IPv4 packet format. And for IPv6, what will be the value of the version? The value of the version will be 6 because IPv6 means what? The value of the version field will be 6. So it basically defines the whichever version you are using, whichever version's IP address you are using, this version field defines that. Next is the traffic class. Next is the traffic class. Now, what this traffic class field defines? This is used to distinguish between the payloads. This will be distinguished between the payloads in the different requirements. This distinguish payloads in different requirements. Next is the flow level. Now, flow level, why this flow level is used? Flow level field is used. This flow level field is used to control the flow of data. That means the flow of the data. To control this flow of data, we uses this flow level field. Or giving some information, special information, we can give it with the flow level. So using the flow level, we can give some special information. So for giving some special information, we uses this flow level. Means basically it is used to provide special handling. It is used for basically special handling for a particular data flow. That means for flow of data, it is used for specially handling that particular flow. This flow level field is used. and this flow level field is of 20 bytes. This flow level will be 20 bytes. This is the flow level field. Then next is the payload length. Next is the payload length. Now, what is the payload length? Payload length, it is the length of the IP datagram, excluding the header, because that means this payload, this total payload lengths, whatever the payload, that means the data we want to transmit, the length of the data that we want to transmit, excluding the header, whatever the length of the data that is to be we are transmitting, that the length is called the payload length. This will be called the payload length. So this field, payload length field, will do that. And it is of 16 bytes. It is of 16 bytes. Then next is the next header. Now it defines the header, follows the base header in the datagram. So I have not said that some headers are also present. So that are called Icmp header, TCP, transmission control protocol, UDP, user datagram protocol. These are the protocols that are present. We will see that after on in the next classes. We will see that what is the TCP, whatever the UDP. But now you know that these are the headers. These are the headers present, and we call it as the next header. So whatever it defines the header that follows the base header in the datagram. So in the next header, if the code is 2, let's say if in the next header we use the code 2, that means we are using the Icmp header. If the code value is 6, then we can say we are using the TCP header. Or if the code value is 17, that means we are using the UDP header. So this is the next header. The next header we use. Sometimes this next header we use. So this next header, if these values are came, then that means these types of headers are used. So this is the next header field contents. And hop limit is, it is simply used to time to live. That means maximum hops that the packet can go. The maximum hops that the packet can go. Let's say we have four hops present. So let's say that 4 hops are present. That means we can go up to 4 hop. That means 4 hop we can go, and after that it is not reached to the destination. If after going 4 hop the packet doesn't reach to the destination, that means we have to discard the packet. That means if we have seen that this is the hop count, we say this is the source and let's say this is the destination. Between them there are devices, or say this is the devices present. Let's say we are saying that there are 4 hops present, and let's say there are 5 hops are present. So 1 hop, 2 hop, 3 hop, and 4 hops. But after going 4 hops, it is said that maximum 4, after 4 hops the packet will go. After that, if these 4 hops we go up to 4 hops, but our destination is here, that means we have to go another hop, but our maximum hop count is given 4. That means the packet will be discarded from here. The packet will be discarded from here, because if our maximum hop is 5, then this packet able to transmit to the destination. Otherwise the packet cannot be transmitted to the destination, because here we are seeing that 5 hops are present, but our maximum hop is 4. That means up to 4 this will able to go. This packet will able to go maximum up to 4 hops, but here the 5 hops are present. So that means the packet will be discarded and it will not able to reach the destination. To reach the destination, it has to be used 5 hops. Okay, so this means this field is used simply the time to live, that the maximum hops the packet can go. That maximum hops the packet can go. This field suggests that. And source address and the destination address is, it is already known to you, that means the source IP address, the IP address that is used by the source and the IP address that is used by the destination. This will be used by this, defines these two fields. So this is all about the packet format, the packet format that is used in the IPv6, the packet format that is used in the IPv6. Now the last thing that is in the IPv6 is the changes that is made in the IPv6. Now, first point, it is already discussed that the larger address space. So previously it was 2 to the power 32. Now in the IPv6, it becomes 2 to the power 128. So if we subtract, then we will get 2 to the power 96 value. So that means 2 to the power 96 times more address than IPv4, because IPv4 there is 2 to the power 32, but here this is 2 to the power 128. That means if we subtract, then we are getting 2 to the power 96. That means 2 to the power 96 times more address is possible in this IPv6, and it has more address than IPv4. And also the better header format, there is a header format is better than IPv6, because in IPv6 header format options are separated from the base header, because this IPv6 header format, this is separated from the base header. And there is new options for additional functionalities in IPv6 which is not present in the IPv4. For this, additional functionalities are present in the IPv6, but in the IPv4 the additional functionalities are not able to, there is not present the additional functionalities. And allowance for extension, that means it is designed to allow extension in a protocol if required by the new technologies or application. That means it is designed in such a way that it can allow the extension. It can allow the extension in a protocol, and if the protocol requires some new technologies and application to allowance that, this IPv6 header response is much good. And for the support of resource allocation and for support for the resource allocation, generally in the IPv6 type of the service field, you can see in the IPv4, if you remember, in the IPv4 there is a field that is the service field. Name of the field is the service field. But in IPv6 we generally doesn't use that IPv6 service field. And here the two new fields are introduced. These two new fields are the traffic class and another one is the flow level. These two we use here. These two field we use here, and these two fields are basically used to request the special handling of the packet. And there is for support for more security. So IPv4 increases the security, encryption and authentication. So it supports the more security than the IPv4. Okay. It is clear to everyone? It is clear?
Yes, sir.
Okay. So it provides more security and authentication. That is encryptions and authentication. It provides more security. IPv6 increases the security. So this is all about our IPv6 packets format. And this is the changes that changes